To test the new nScope API, I have developed a board with all of the next-gen components on the nScope. And one of the things that we're really looking forward to is the ability to control the inputs and outputs programmatically directly from Python or MATLAB. So as you can see on this board, I have a transformer that I ripped out of a power supply for an inductor, a potentiometer for a variable resistor, and a capacitor back to ground. The circuit diagram for this looks like this. I've got a pulse generator hooked up to a series LRC circuit. Channel 0 is measuring the pulse output, and channel 1 is measuring the voltage across the capacitor as the circuit output. What I'm going to do is measure 1 second of data with a 200 millisecond pulse to measure the step response of the system. We can see that when we run the Python test pulse, the data spits across the screen and we get the output of the circuit. The green channel is the voltage across the capacitor, which shows a very underdamped system. We just increase the series resistance by changing the potentiometer. We can see that the system becomes much more critically damped. Now, to make things a little more interesting, what I'm going to do is instead of having a pulse generator, I'm going to use a sine wave generator as well. And while it's taking data, I'm going to change the frequency of the sine wave and see how the system responds to different frequencies of input. All we have to do is run the Python script I've written to control the sine wave frequency. And after 10 seconds of data collection, we see a nice even amplitude input and an output amplitude that peaks at around the system resonance of about 40 hertz.